Today's subject is data cleansing using Databricks, a product I'm very interested in. My company uses it, but I need to learn more about it. Keeping data clean is very important, and I'm looking very forward to this. So presented by Sam Nasr. Thank you very much, Sam, for being with us today. Sam has been a software developer since 1995, focusing mostly on Microsoft technologies. He's a senior software engineer with NIS Technologies, where he consults and teaches clients about latest .NET technologies. Sam has achieved multiple certifications from Microsoft, MCSA, MCAD, MCTS, MCT, and he is the leader of the Cleveland C# since 2003. I think you got us beat by 1 year there, Sam.
It's all right. We're still on the same team.
All right, that's right. That's right. In addition, he's the leader of the .NET Study Group, Azure Cleveland User Group, an author for Visual Studio Magazine, LinkedIn Learning, and a 8 times Microsoft MVP. When not coding, Sam loves spending time with his family and friends or volunteering at his local church. You can learn more about Sam by visiting linktree/Sam Nasr. Thank you, Sam.
Thank you, Tolga. I know that was a very long-winded description and explanation, but I appreciate the intro. And thank you all for joining. And I wanted to go ahead and get started. And since Tolga did a great job with the intro, we'll go ahead and just skip through that. But I also wanted to mention the 2 user groups that I run from the Cleveland area. We meet every month. The meetings are free of charge and open to the public. I run both the Azure Cleveland User Group as well as the Cleveland C# User Group, as Tolga had mentioned. And the links for both of those groups are available on meetup.com as listed there on the slide. In addition, while it's still fresh in my mind, shortly before we started the meeting, we talked about an event called SQL Saturday. So I'll go ahead and share that. And what SQL Saturday is, it's an all-day event of SQL-related topics relating to SQL Server, as well as Cosmos DB, Postgres, and a variety of other databases. It's a great way to learn about the various database products, the technologies, and then also to be able to network with others that work in data. So in addition, they have meetings worldwide at various cities, and the meetings tend to repeat yearly. So if you miss this year's meeting, there's always next year. They're free of charge, and it's a great opportunity to both learn and network. And the URL for that is sqlsaturday.com. So getting back into the core of tonight's presentation, we're going to be talking about data cleansing. So first of all, why do we need to bother with data cleansing? Right? We already have the data in the database. Let's just start developing machine learning models out of it. Well, first and foremost, you want to avoid garbage in, garbage out. You start with bad data, you're going to end up with a bad model, right? This has been something that I have learned since I started coding in high school, and it still applies today. It is the most time-consuming task, so it gets a little bit frustrating because a lot of times management would want to implement an ML model or some AI feature, but this is the most time-consuming feature. However, it is the most necessary because it is the foundation that you're building everything on. So one of the things that you ought to ask is, were all options equally visible whenever we're collecting data? And what I mean by that is, let me jump to a demo. And this is something that I had fabricated. Where did it go? There it is. So we've all booked airline tickets at one point in the past, right? And there's always options for upgrades to choose from. But then you'll notice, without mentioning any names, some airlines do something a little bit fishy, right? So looking at this, as a consumer, you typically want the cheapest airline ticket, right? So which option would you likely choose from these three? All right, so Tolga's on mute, but I think he's saying the economy class. Of course, right? That's the immediate go-to. However, in some cases, you'll see things like the link is at the bottom, but it's kind of hidden due to the font and the color that's being used, right? So here I can continue on with the standard pricing at no extra charge. So the point that I'm trying to convey here is the first thing you need to look at as far as data cleansing, how was this data collected? In this scenario, we're essentially twisting the user's arm, but doing it in a very subtle way, right? We're hiding that free option and we're giving them 3 upgraded options where we can collect more money. So that was the point of that example. Now, getting back into it, we want to ensure also that users were not influenced by other factors. What I mean by that is I was volunteering at an event at our church, and what we did was we said we have 3 buckets for people to volunteer, and we're going to draw a name from each bucket, and there's an Amazon gift card. So what did everyone do? They put all their names in all 3 buckets. And then when we went to actually contact them, everyone kept coming up with excuses. I don't have time to volunteer. This is not my cup of tea. Apparently, they were just influenced by the Amazon gift certificate, right? So this is, again, one of the first steps that we need to cover, is to ensure that we're not influencing the user by any other external means. We also want to look at, was the data manually entered, or was it collected in an automated fashion? If it's manually entered, it's more subject to fat fingering, items being left out. God forbid, should you get the data in an Excel or a spreadsheet of some sort. Nothing against Excel, but obviously we all know Excel is free entry. You can enter in whatever in any cell. And so if it's manually entered, you need to pay closer attention to all the errors that could be built into it. Another reason is we want to prevent what's called overfitting. And what overfitting is if we have the data where it is not a nice collection, meaning it's covering all the bases and the various scenarios, but rather it is kind of in a finite silo, then overfitting is essentially where the model will memorize what the data is, as opposed to getting an algorithm based on that data. So in order to remove overfitting, we want to remove any noise or outliers, for one. We also want to fix any inconsistent labels. So sometimes, for example, again, this is mostly if the data was manually entered. In some cases, they will put in the number 1 versus spelling it out as ONE. So obviously that's going to cause problems when we're doing a machine learning model based on that data. And of course, a big one is handling missing values. How do we handle that? And we'll talk about various techniques for filling that in. And of course, we want to remove redundant or irrelevant features. So take, for example, when we're talking about home prices. Obviously, we've all have been down the road of purchasing a home, and we know what's involved in it. What are the various features that drive the price of the home? You have the number of bedrooms, bathrooms, location, of course, and a variety of other things. But in some cases, in the data or each record, you may have some redundant features. So I can specify the land square footage or the acreage, but I should not specify both, right? That's going to be redundant. I should only have one version of the truth, meaning only one attribute, not multiple attributes of that. Because if one is messed up or slightly off, it's going to throw off the model. Also, I don't want to have multiple redundant records of the same thing, because now that's going to skew my model into one direction. I also want to normalize and scale the features, meaning if I'm looking at salary or the price of a home, did the user enter in 100 with the intention that it's 100K, 100,000, or are they entering in all 6 zeros or all 5 zeros rather? So that's something also to keep in mind, is that we want everything to be normalized and on the same scale. Let me just pause here and see if there's any questions in chat. And so far there are none. I should also mention, feel free to jump in at any point in time, either verbally, and can take questions as they come. Moving right along. Another thing that is overlooked many times when we're starting with a machine learning project is utilizing the subject matter expert, or SME. So this is a common mistake where a developer would be given a set of data and told to develop a model around it, but that developer doesn't necessarily know how the business works. The example of real estate, since we can all relate to it, a developer may look at a set of data and figure, well, bedrooms and bathrooms is the key thing, or just zip code alone, and we'll look at the price, and that's what we're going to build our model on. And obviously that would be incorrect. So for building a model for the home pricing, it includes many features, and only one label being the price. Also, when starting a machine learning project, the key thing is, the very beginning, identify a specific objective statement. I was actually talking to a colleague, and I kid you not, the management team went up to him, executive management for that matter, and they said, use this AI thing to make us money. Do whatever it takes. You got access to the data, build us something in AI. That's not really the right way to go about things. You need to have a specific objective of what it is that you're trying to do. What is it you're trying to get out of that machine learning model? So the subject matter expert, they can identify key input values. And also they can note the span of time or date. So for example, if we look at home prices, the price of a home back in the 80s is far different than the price of the home in 2026. So, with historical data, it's important to build in the date so that we can see the trend, as opposed to excluding that where it can skew the model. Typically, more records means that it's a more accurate model. However, the key idea here is to have better context to have a more accurate model. So by context, I mean, when we're describing a home price, what are the features around it that dictate that price? Let's give it context, not just a specific feature. Aside from the various factors that I mentioned, you also need to take into consideration, has the home had any fire damage, any termite damage? Is it in a flood zone? All these will also impact the price of the home overall. So it's not just more records, but also everything needs to have the context around it. So when we're selecting columns for training, we need to have an ID field or a unique identifier. When forecasting, we need to look at either the exact date or the month and year. That needs to be normalized. We need to look at either categories or specifics. So for example, are we categorizing things by state, or are we going to break it down into zip code and city? And is the date relevant for each record? So obviously we need to look at housing prices and how it is affiliated with the date. But in some cases, the date really doesn't matter. For example, when we look at LDL versus heart disease. So obviously someone having a high cholesterol level back in the 80s will be impacted by heart disease in the same way that they are impacted in 2026. So after mentioning all these things of where things can go wrong, what we need to watch out for, essentially with data cleansing, the objectives are data normalization. We need to make sure that we have good, accurate data with the proper relationships. We need to replace any missing values and remove duplicate data. Another thing to look at is the data types and the structures. So does the data adhere to the data types? And like I mentioned earlier, when someone's entering the quantity, are they entering in ONE or the number 1? That obviously the data type matters there, and we need to have everything on a consistent level. We need to check for the data integrity to make sure that it matches the schema. In the case where I am handed data in a flat text file or in a spreadsheet, obviously those two items don't necessarily maintain relationships, nor do they adhere to a schema. So if I'm importing that data, I need to make sure that it imports correctly into the specified schema. Also, for handling required and optional fields, if some optional fields are there, and in some cases they're populated, some cases they're not, what am I going to do for those items if I need that optional field as a feature? And for all inputs must be required, otherwise the results may not be meaningful. So I need to identify which fields are a must-have, or what am I going to do to be able to fill in those missing pieces of data. In addition, where I talked about the subject matter expert and helping to define the business, so some of the things that I need to look at for the business logic and the data relationship. For example, if I'm working in a hospital or a medical or a procedure that applies to a male may not be female, right, and vice versa. So I need to understand the logic there as well. In the case of Tolga, for example, working at Advanced Auto Parts, if I'm a motorcycle owner, I can't come in and ask for air conditioning parts, right, for an AC unit. That doesn't fly. Motorcycles don't have AC. Or if I have a landscaping company, I can't have snow removal service in summer months. So if I'm given data that shows there was snow removal done in July, obviously something is wrong there. So I need to tie it in and make sure that my business logic ties in with the data relationship. Also, scan for distinct values, so that way I can see the range of the various values that I have. So for missing data, how can we resolve that if we have rows with missing fields? First, we can reverse engineer it, meaning I can, depending on the logic and the situation, that option may be feasible in the sense that I can look on the salary based on title, years of experience, and then I can kind of deduce what type of salary that person would have. Or for example, let's say that there is, I'm looking at the employees in a specific department, and I see that one employee has their last name is missing, but first name is Sam. Well, if I know that there's only one Sam that works in engineering, obviously I can populate his last name easily. Another way of populating missing data is what's called mice. And we'll talk about that later, where it's basically multiple imputed computation evaluation, if I got that acronym correctly. But basically what it does is it averages things out, and then it runs through multiple imputations and essentially assessing the value that was inserted. And in some cases, it's literally hits the nail right on the head. Another thing I could do is if I have missing data or a field that's missing, I can replace it with a custom value so that in the end, I can query all my data and see, for example, category 999 and have that stand aside. And in some cases, I may remove all those fields or remove all those records and reprocess my data again without those records. Another popular method for handling missing data is replacing the value with either the mean, the median, or the mode. And these are all different types of averages that we'll talk about in just a little bit and discuss the pros and the cons of that. And then my favorite method, just remove the entire row altogether, right? Now this is dependent on how much data I have and how much impact will removing that row impact my training data. For example, if I have 100 rows with 2 rows that have some missing data, that may impact it a lot more than if I had 10,000 rows with only 2 that had missing data. So that's an evaluation. It's kind of a judgment call of whether to remove that data or not. And then another method that we'll look at is using probabilistic and principal component analysis. And that is a way where I can shrink down the data set into go, for example, from 5 fields down to 2, but yet still maintain that relationship. I will tell you in advance that a lot of this is built on some heavy-duty linear algebra, which I will not be able to get to. So we're going to look at it only from implementing some Python code in Databricks. And let me pause here and see if there's any questions or comments. All right, so
one thing, Sam. I mean, when you're talking about making modifications and taking action here, I'm assuming the original data set still remains, and we're just modifying like a copy so that we can, if we think we screwed up, go back and, you know, readjust what we're modifying. And
absolutely. Yeah, so one cardinal rule that I live by, whether in machine learning or otherwise, whenever I receive customer data, I always make a copy of it and store that off, archive it, and then I use that copied data and then work from it. But always maintain the original set of data that you receive from your trading partners, because as we all know, things always go wrong in IT, right? We need to be able to identify where it went wrong and and be able to get to the core of it. Ronald had a question. Use AI 2-3 profit. I don't understand the question there, Ron. Feel free to.
It's a reference to an old meme. Number 1, use AI. Number 2, something. Number 3, profit.
I think you're relating to the example that I mentioned about the colleague where he was told to build something AI.
Yeah, that makes us money.
Solution looking for a problem.
Exactly. Right. All right. Feel free to come off of mute or enter questions into chat. Let's continue on. All right, so Databricks. What is Databricks? It is a cloud-based data intelligence platform, and it utilizes Apache Spark, and it uses the lakehouse architecture that encompasses data warehousing or data lakes. And for those of you not familiar with data lakes, it's essentially a data store that allows me to put in just about any type of data, whether it's structured or unstructured. So some of the structured data would be like database files relating to SQL Server or tables. Unstructured would be flat files, Word documents, images, that sort of thing. It allows me to do processing on big data and building machine learning models, and it gives me the flexibility to utilize a variety of different languages, such as Python, SQL, or R. And as we'll see in the demo, everything is essentially web-based, connected through Azure, and I'm able to open up notebooks and be able to execute code just like I would with Jupyter Notebooks or Azure Notebooks. So we talked about one method for populating missing fields, and that was mice, also known as multiple imputation by chained equations. And this is a powerful iterative method where it utilizes the missing data, populates it with an average at first, and then continues to run through multiple cycles to repeatedly guess the missing value. And after multiple iterations, it's able to identify that missing value or give it a best guess. And like I said, works fairly well. So this is ideal for complex data sets with non-random or interrelated variables. Looking more at mice. So if we have a data set, for example, like age and income and education. So obviously, typically that's a linear type of model where, you know, the higher you are in age, the more you're going to make. Similarly with education. So this is for the example that we're going to be using. And so the way it's going to work is it's going to fill in the income with the mean average, and then it's going to utilize the income using the age and education, impute the income missing value based on that model that it developed in the third step, and then continue to iterate through it multiple times to ensure that this cycle or that value is correct after doing the several iterations.
Would that value then be weighted differently in a machine learning algorithm, or would it stay the same?
That's a good question. Would it be weighted differently or would it stay the same? I think it would depend on your machine learning model and how you configure it. Basically, mice is just a way for filling in the missing value. It is not for building a machine learning model off of it. It's just for cleansing the data, if you will, by populating missing values.
So with the value itself, we're saying that is inferred data at that point. We're saying, okay, this is projected based on other values.
Right.
So in my mind, that would have less power than something user input. Would you agree and weight that differently in the model, or just keep it the same?
So you could adjust that in the model by utilizing yet another field in that row. And let me show you what I mean by that. If we could. I'm sorry?
I'm not trying to sidetrack you from your.
No, not at all. It's actually a very good question. But let me answer it by going through the demo. And here we are. And as I mentioned, it is a web-based tool for Databricks, that is. And so this is through my Azure subscription. And let's pull up the mice example. And as you see, it's basically notebook fashion. It's all web-based. I have my workspace available with all the various code files. And then I have the mice example opened up. What I'm going to do here is I'm going to install the scikit-learn. And then I'm going to restart the Python engine and then do the import for the library. Here I'm just printing the version of the sklearn. I'm doing some additional imports for modules and libraries. And then I'm going to create a random data set. And I specified specifically that I need to have some rows that are going to be null. And it's going to print the original data. And here is where I'm setting my mice imputer. And I'm saying that it's going to run through it 10 times. And then I'm going to fit the data. And then I'm going to print it out after the data is cleansed. So let me go ahead and clear the output. And we'll go ahead and run it again. I should have pulled up a music track while we're waiting for this to run. Maybe a Jeopardy theme. All right, so as mentioned, what it's going to do, as stated here, it's going to print the original data with the missing values, and then it's going to do the processing on mice, and then it's going to, where is it? And then it's going to print the imputed data set that has everything with the filled in values. So looking at that, I see that I have my original data here. The age and the income and education are specified, except for a couple records where it's intentionally missing. And then as it stepped through it, we see that we have at age 25, the income would be 50,000 with 12 years of education. Or 35, it would be 70,000 with 14 years of education. And then of course, so a perfect fit for that would be at the age of 30, the income would be 60,000. So I ran through multiple iterations of that. And then in addition, or the person of age 40 would be making 80,000. So at this stage, all it did was it built me a completed data set. What I do with that data set is completely up to me, whether I run it through another machine learning model or repopulate it in the database again. Does that answer your question, Daniel? Excellent. Any other questions at this point?
Yes, Sam.
Go ahead, Sally.
So whatever I'm seeing here, all the work is done by scientific learned libraries. What is the role of Databricks here?
So the role of Databricks is essentially, it's a platform where I can execute my Python code as well as have access to the data. It is essentially one-stop shopping for me to be able to house the data, do some analytics on it, to be able to query it. And then in this case, I ran some Python code against it.
Okay.
And like I said, it's all web-based, so I didn't have to install anything locally on my machine.
Yeah. And so, because I do the same using VS Code.
Multiple ways to skin a cat, that's true. However, with VS Code, there's no way to store the data, right? You have to store it in a database.
Yes.
This is your one-stop shopping.
So is Databricks more of a orchestrator of different tools to, take and process data? So Databricks itself doesn't do processing; it's just a mechanism for processing data. Is that understanding right, or is that off?
There's other tools that are built into it that obviously we're not going to have time to cover tonight. But yeah, you can build machine learning models off of it, do additional analytics. There's a variety of things you can do in it.
Sam, perhaps you covered this, but I don't see how it knows to operate only on the initially NaN numbers.
So going through the code. So what I did was I am building a data set of random data here.
Yep.
And because I am utilizing the iterative imputer, it is going through and essentially populating the missing fields within that record set. So it's not necessarily where I identify a specific column, but rather it's going through the entire data set.
Filling in any blanks.
Correct.
But how do you, in the next steps, fit and transform, convert back, how do you know to only alter the data that was initially NaN? Or is that not important to you?
Well, no, it's already identified as NaN. When I started, it's already in the data frame that's generated here. And so this data is mentioned, as you see, in multiple other places. So here I say to transform that data, and it's going to produce a new record set called imputed data.
Oh, I see. So
and that's what I print at the bottom.
Okay. So my computer. Oh, right. Okay. So yeah, sorry, missed it. Thank you.
All good. Sa, you had a comment. What do you mean by training?
No, I was thinking something else. But
Okay.
I do have current task that I am doing in my organization with regards to the data cleaning. If provided time, I can explain and get some insight how that can be tackled. This is with regards to the volunteer data that we currently have.
Okay, sure. I will make information available later. And I always say, just because the meeting comes to an end doesn't mean the dialogue stops here. I always encourage people to reach out to me, email, or we can arrange for an online meeting, and I'd be happy to help with any questions or projects. All right, very good. Okay, so any other questions regarding mice, the algorithm that is?
How does data, I mean, obviously right now you can just press play and it'll execute this, but is Databricks normally, at least in my company, I think we use it in an automated fashion. How would you automate something like this? Is it, I see jobs and pipelines on the left side, or maybe I'm getting ahead. Maybe you're going to talk about all of that. But I was like this specific notebook. It looks like it's just you would run this manually, or am I missing something there?
No, you are correct. For demo purposes, yeah, I do run this manually. And yes, there is other ways of setting it up so that it's automated, and that's something that I'll talk about later. But essentially, the way I approach things, build a castle, you need to be able to put 2 bricks on top of each other and know how they fit, right? So in the same manner, what I show at the end is a slide that has the entire pipeline from beginning to end, but you need to know what's happening in between and how the data is being cleansed in order to be able to get into a machine learning model that can then be tested and implemented. So yeah, you're stealing my thunder in a way, Tolga.
Nice. Okay. Thank you, Sam.
You're very welcome. Any other questions or comments? All right, we're off to a great start. I appreciate all the feedback. Let's keep that going, and I promise to not go beyond 7:30, as much as possible, that is. All right, so getting back into it. All right, so another thing that we need to consider is what's called PCA, and that is short for Principal Components Analysis. And what this allows me to do is to be able to take a rather rich data set that has multiple features. And as we see here, if we have a data set about cars, which I'm a huge fanatic of, by the way, there are many attributes that describe features of a car. So we have horsepower, engine size, weight, efficiency, so on and so forth. 8 different attributes. How can we maintain that relationship and be able to slim down that data so that we're not dealing with such a robust database? So with PCA, it simplifies complex data sets by reducing the number of variables or features. In machine learning, we call these various variables features, and then the output or the final determination is called the label. So features of a home would be number of bedrooms, bathrooms, zip code, and then the label would be the price, of course. So with PCA, it transforms the original features into a new set of features, but again, slimmed down. And we call those slimmed down features the principal components. And it focuses on preserving the variance or how the data is spread out. Again, linear algebra, eigenvectors and eigenvalues, which I can only pronounce. I can't get into much more detail than that. But essentially, once it reduces that data set down, it is then using deterministic values to be able to populate those missing fields. And so the advantage of that is that it allows for compressed data. It allows us to have less noise, and removes any uncorrelated features. And we have a clearer structure. And of course, in the end, we have a better performing ML model from that data that's being produced. And so let's jump into a demo of PCA. And we'll go again to Databricks. So in a similar fashion, I'm using Python code here, where I am importing the various libraries. I am then creating some random data. That's going to be 100 rows by 5 columns. And then I'm going to introduce some missing values intentionally every 10th row. And then this is the data that's going to be displayed with raw feature 1 through 5. Then I'm defining my imputed data, which will take the values and it will fill in anything that's null or missing. And then I'll display the missing features, or the filled data rather, with all the 5 features. And then I'm going to make a call for PCA, and I'm going to reduce this down to just 2 components. So I'm going from 5 columns down to 2, preserving that relationship. And then I'm going to display everything to the end user, just using the first 2 columns. So again, I will clear the output, and we'll hit run. And there it produced the 5 rows, the raw data. And we see here that every 10th row is null. The 1.2 that you see here is just basically an indication that this is a double data type that's being produced here. So we have 100 rows that were generated. Then we scroll down and we see the filled data, where we have every 10th row is now filled. And then we scroll down even further and we see that it has now compiled these 4 or these 5 columns down into 2 columns, preserving the relationship between the feature and the label. So what I want you to get from this is the ability that I can, number 1, fill in the missing values, and number 2, the ability to shrink a large data set into a smaller one that has the same relationship as the original, where I can now use my ML model and train it on that data. And just like we had seen with mice, this is not the final model, but rather it is the data that I can then take into my model for training. Make sense? Let me pause here for any questions or comments. I got 1 thumbs up, 2 thumbs up. Do I hear 3? All right, maybe not, but I'll keep waiting for it. If there's no questions, we can move on. We got a 3rd. Excellent. Thank you, Brian. All right, so getting back into our presentation. So next is custom substitution values. Sorry, my PowerPoint's a little messed up here, but whenever I have a value that's missing, I can utilize a custom value, such as -999, or just simply state that it's unknown. So this is needed only when the missingness has some meaning, meaning that in some cases, like for example, I send out a survey and some questions are left blank on the form, or some answers rather are left blank on the form. So does that have meaning to me, or is that something that I should fill in with a missing value? I can utilize decision trees or random forests, and gradient boosting will handle this very well. And again, that's going into mathematics world and a little bit deep with that. Or I can use the standard imputation, meaning to populate that missing value using one of the 3 types of averages, the mean, median, or mode. However, that can also introduce a bias, and we'll talk more about that when we get into the averages. The advantage of using a custom substitution value is that it allows me to preserve the row count. So this way I don't have to discard any data, but rather I can use the entire data set. And as stated at the bottom, a custom value avoids making assumptions about the distribution. So obviously I don't have to guess by using the average. I can just state a value that's going to be off the charts, if you will, and that will stand out that this is going to be used for my training. Now, looking at averages, mean versus median versus mode. As we see here, basically this sums it up where I have the mean. This is the sum of all values divided by the number of values. So if I start with a data set that contains 2, 3, 3, 4, and 100, obviously the 100 here is the outlier, and most of my data is on the lower end of the spectrum. If I use the mean, where I add in all the values and divide it by the number of values, I have an average mean of 22.4. If I use the median, which is essentially identifying the middle value in that data set, it produces a value of 3, and mode is the most frequently used value, and in this case, it would be the number 3. So as we see here, that mean is the most sensitive to outliers. So I have a single outlier, and it has impacted the data or the average number significantly, whereas the other types of averages were on the lower end of the spectrum that was more of a better fit. So if I replace with mean, that means it's filling, it fills the missing numerical values with the features average. It's sensitive to outliers, as I had mentioned, but it can reduce data variability and bias if missingness isn't random. If I choose median, then this substitutes the missing values of the feature's middle value. So this is more robust to outliers, meaning that it can resist outliers more as compared to the mean average. And this is better for skewed or non-normally distributed data. So as we had seen earlier, we had the one value that was way out there, and utilizing the median average handled it better because it stuck more to the other numbers that were stated there in the data set. Same thing with mode. Ideal for categorical data where you have, you're choosing from a finite set of items, whether it's a color, a job title, or any other categorical information. It utilizes or imputes the most frequent category in that feature. And it can skew the class distribution if one category is already dominant. So obviously, because mode looks at the most repeated value, if I don't have a Y class distribution or one class is represented more than others, obviously that will skew the data. Another option, like we talked about, is removing the entire row. So this is effective when the number of rows is number of affected rows, meaning the ones that have the missing values, when that number is small. Obviously, this can lead to a loss of valuable data and bias if it's systematic, happens regularly, or if you have a large number of rows that have missing data from a smaller data set, that's going to have a bigger impact. And the one thing I always caution other developers on is track the number of rows that were removed versus the total rows, and also document them. And this kind of ties into a point that Tolga brought up earlier. Should I copy customer data before I start massaging it and cleansing it, or should I just use it? So you always want to maintain a copy of the original data untouched, and then make a copy of it and start working on that. Let me pause here and see if there's any questions. All right, I know I'm throwing out a lot at you, so feel free to stop me at any point in time with any questions. It's a pretty big topic, but like I said, I'll try to keep everything under 7:30. All right.
Are you going to also go into other data dirtiness things like invalid values or mistaken values or different norms for rating something and that kind of things?
Yes, there is more to come on that, and we'll touch on that in another example as well.
Thank you.
You're very welcome. Okay, another option is to remove the entire column where I have a lot of missing values. And again, if I'm going to be discarding that, you have to look is if the entire feature or discards entire feature if missing data dominates, meaning that I have for that one column, I have a lot of values that are missing. Then in that case, I would question, should I remove that column altogether? But if it is something that's critical to my machine learning model, after asking the subject matter expert and doing some analysis, that's an evaluation that I have to determine if that's a possibility or not. So this is appropriate when the column adds little information or can't be recovered meaningfully. And I think that's self-explanatory. And it may weaken the model performance if the feature was important. So again, another thing to keep in mind. Outliers. So with that is something that we also need to go back to the subject matter expert about the case of the outlier values. For example, if I have a listing of home prices, one of the things that I'm going to demonstrate is essentially using a scatter plot and seeing where all the values lie to quickly identify the peaks and the valleys in my data, especially the outlying values. And in that case, I would have to question, why is the price of a specific home so low in comparison to the others that we're working on? Maybe there is another feature that I am missing, such as fire damage, termite damage, any other thing that may impact the price of the home. For example, some homes are condemned where they cannot be lived in, and so the price of that property drops significantly. So for that, utilize data visualization, where you can quickly see where the outliers are at and have a good idea of the data overall. A more manual way of doing it is to scan for the min and the max. And then also utilizing SQL, you can check for duplicate records and be able to remove those. And then, of course, null values or missing values, as we have talked about. So some biases. We want to prevent biases in our data. And to do that, we want to have good representation of all the candidate features or inputs across the spectrum. So how many bedrooms, what is the maximum in my area? And do I have a good representation of all the various homes of my area to be able to identify what the home pricing is and be able to build a machine learning model off of it? And then when it comes to product sales, am I looking for the entire week or only for specific certain days? Keep in mind, when it comes to flowers, what are the busiest days for flower shops? Valentine's Day and Mother's Day, right? So if I'm only going to be looking at certain parts of the data, I need to keep that into consideration. Product sales for Valentine's Day, they go through the roof, right? But other times of the year, it's rather even keel. So that's something that I also need to keep in mind. And then last is, well, not last, but another thing that I consider critical is documenting the data that was used for the machine learning model. More specifically, the number of records used versus the total records, which essentially is stating how many records were removed for various reasons. And the key thing is here, I want to document it and document it well. So be verbose about it. Keep in mind that you're not just writing this for yourself, that you're going to use it tomorrow or next week, but rather 6 months down the road or years down the road, or for a colleague who may not have ever met you after you leave your current position. So you need to write it be verbose about it, be very descriptive, And I'm sure a lot of us can relate to going back to some old piece of code that we haven't touched in 6 months or a year, and you're like, what was I thinking, right? So imagine if it was a colleague that was going through that while you're on vacation, and now they can't understand what's going on. So document it well and be very descriptive about it. Specify the unique value counts, missing value counts, min, max, and mean deviation of that data, rows or columns that were deleted. So as you see here, I'm saying be verbose and be very descriptive about the data that was eventually used for the model. Also, another thing that we want to utilize is relational databases. So in many of our jobs, that is something that we use on a regular day-to-day basis. However, in some cases, you are going to be receiving data in a non-relational database format. What I would do, first thing, set up a relational database and import that data into it. And the reason for that is, as you're importing it, it's automatically doing the validation, checking the data schema. Obviously, if you're trying to import text data into a numerical field, that import is going to fail. So it's a quick way of identifying things that don't fit into the schema, as well as the numeric range. So with SQL, we can set it up so that we can identify lower bounds and upper bounds for ranges. For example, if I am in the airline industry, obviously I know there's never going to be a ticket lower than $50, for example, or $100. And likewise, I know that it will never be a ticket that is over $10,000, for example. Well, maybe that's a little high, but you get the picture. The point is, I want to identify lower and upper bounds, have that constraint, so as I'm importing data, it's constantly checking for that. And I want to standardize on my numerical values. So things like salary, hourly rate, am I going to the second decimal place? Am I using no decimals? Am I rounding up to the nearest integer? How am I going to standardize on my numerical values? Also, formatting for phone numbers and emails. I need to check to see that it's a valid email, that it ends with a .com or .org or any of the relevant domains. Also with phone numbers, removing dashes or making sure that everything falls into the 3-3-4 format. I want to make sure everything is consistent in my data. Any questions so far?
Yeah, Sam, if you're extracting data, you're validating data by importing, how do you, I mean, there's potentially very many constraints in a single record. How do you document what's causing the data to be
Failing?
Yes, thank you.
Yeah. I mean, obviously you would identify which rows are failing, and in some cases you may need to go through and maybe run one of the algorithms like mice or PCA against it to fix up the data a little bit. Again, depends on the situation. But with the importing, it's quickly identifying where the problem lies. And obviously, if you have multiple rows that have issues, that's going to require each row to be addressed in a different way, or maybe all of them can be addressed in a singular way, meaning that, let's say, all of them have the number 1 for quantity spelled out, O-N-E. So you could do a quick search and replace through that raw data before re-importing it. So it just depends on that specific scenario.
Okay. So it comes down to hand analysis.
I mean, there is a manual and there is an automated portion to it. But essentially, once you understand and what you're doing, you can automate that to handle the various data sets coming down the road.
Okay.
Would the databases journal or log which condition didn't meet the constraint and tell you? Like, for example, would it know it didn't meet the, I mean, we're just looking at the constraint here, but of course these are placeholders. Like if there is, you know, 5 different, if there's constraints on 5 different values, how do you know it failed because, let's say, the age is out of bounds, for example?
So typically, like when I'm using SQL Server for that, and when I import it, let's say from a spreadsheet, it will stop and say record number 532, the constraint failed. And so I would look at that record 532 and take a closer look at it, see where the problem lies.
So would it tell you in there that it's the age that failed the constraint, or would you just say constraints failed? I wonder. Just
I think it would depend on which version of SQL Server you're using, but typically it gave me an error relating to the specific row.
Fair enough.
And of course, it depends on the database product as a whole. I mean, I'm a big fan of SQL Server, so that's what I've been using typically. All right. Any other questions?
When you're doing your import to, let's say, SQL Server, would you be using, let's see, what SQL Server is this product for ingestion?
So there's multiple different formats. You could import it from Excel, import it from a flat text file, whether it's tab delimited or comma delimited. There's several different formats that you can import it from. Does that answer your question?
Yep.
All right, very good. Other questions or comments? Okay. So another feature that's useful in Databricks is utilizing various functions within Python that allows us to do some data cleansing. So here we have a data set, and let's just take a quick look at that. Let me expand the table a little bit. So you see that I have within the name column, essentially the first name is, the first letter is capitalized in each one. And then in some cases, I have a Mr. Gregory Hart. So that needs to be scrubbed. I need to have it a little bit more consistent. And so using this data set as the raw data, I can use it in my PySpark functions where I'm starting off by retrieving the data just by doing a simple query and populating that into a data frame. And then I'm going to go and just make a call to drop NA, which is going to remove any null values. Then I'm going to, I already made the assessment that I'm going to utilize median for age. So I'm using the function for approximate quantile for the age. And then I'm going to fill in the age with the median age. Then I'm going to scan it for duplicates where the name and the social security number are duplicated. And I'm going to drop that. And then I need to filter and make sure that all the ages are older than 18. As I pointed out earlier, the names, they were all, the first letter was capitalized. I want to normalize everything and make it all lowercase. Here, this allows me to do a type conversion where I'm going to cast income as a float, cast birth date as a date, and the ID as an integer. It also gives me the flexibility to rename columns. So now I have the new name that I can set. And now I can produce a new data frame called data frame underscore cleaned or df underscore cleaned. And here for the full name, I'm going to remove any of the non-alphabetic characters. So any special characters will be removed. Here, I'm enforcing the value for the quantity. So if there's ever a quantity that's less than 0 or greater than 100, I'm going to substitute 0 or 100 for that. And then in the end, I'm going to display the data that I set. So while we're doing that, let me go ahead and run that. So here's my raw data. Oops, I just deleted everything. All right, while that's generating, let me focus on the comments. So Tolga was stating SQL Server integration services is what you would use for your imports or something more direct.
I was just asking, we were talking about using importing as a failsafe for, setting some constraints. And I was thinking, and I'm not a big SQL guy, we use Postgres mainly. How would you do imports in SQL or MS SQL, I guess? And I was thinking, is it SSIS? But yeah, how do you typically do relational database imports within Databricks, I guess?
So are you importing from one relational database into another within Databricks?
It's I guess what we were talking about earlier, or maybe I misunderstood you, Sam. Correct me if I'm wrong. Weren't we saying like use schemas or constraints in your database to eliminate some of the bad data?
Correct.
Or were you saying before it even comes to Databricks, do that, not after? maybe I missed the timing there. When would you use?
So Databricks is nothing more than a tool, basically, where I can use to manipulate the data, and in this case, cleansing it, right? So can I use that, or can I use SSIS? Yes and yes. You can use both, either or, really. As far as the phases, do you use Databricks before SSIS or after? It depends on your overall pipeline and how you have things set up. Meaning, am I going to remove nulls after I import into the database or before it? And am I keeping my final data in Databricks, or am I keeping it in SQL Server? It depends on what your flow is.
If you decided to do some pre-processing with Databricks and then you were trying to export it or import it into SQL, how would you do that in Databricks? Is there like a built-in way of sending the data to a RDBMS, or is it like a shell command or something like that you call?
So you can have a database, a relational database built into Databricks, and then you can connect to that through SQL Server and be able to pull the data in that way.
Gotcha. As just a matter of like adding the rows, it'll automatically, obviously, the constraints will exercise. Okay.
It's essentially ETL, right? So I can take it from Databricks and then import it into SQL Server, or vice versa.
I'm with you now.
Okay. Other questions or comments? All right, so looking at where I had left off, so here's my raw data, and you see that I have the name field for name as the string data, and you see that first letter for first name and last name is capitalized. But then if we continue further down, we see that we have the newer cleansed data, where I have Ryan Smith, Maria Jones, and everything is lowercase, and then going through, everything is copacetic with the various fields, or with the various constraints that I had specified here, as far as quantity, as far as there was age limit that was set in here. There it is. And then removing duplicates with where name and SSN are both identical. So it will identify any duplicates and immediately drop those rows. So Sean has a question. Let me address your first question, Sean. There's a jobs and pipeline section on the left sidebar. That might be what you're wanting to know more about. Correct. And again, that's a very detailed topic, but we're looking at, not to overuse the word bricks here, but we're looking for building the building blocks of what's going into an ETL pipeline for your machine learning. So yes, you can utilize the jobs pipelines in the end, but you need to know what goes into it ahead of time for your data cleansing. Your second question, Sean, go ahead. Where did Sean go? All right, while we're waiting for Sean, any other questions or comments? All right, sorry, Tolga, go ahead.
Are you going to have a chance to show off the jobs and pipelines? Just touch in there. Sounds very interesting.
Yeah, just a touch, and let's get into that. So as we mentioned earlier, there's additional tools that are built into Databricks. So you have the Delta Lake, which supports schema enforcement and the evolution. You can also utilize AutoML for doing profiling and the cleaning steps. And then the profiler offers visual summaries for the missing data, as well as the ETL pipeline. Essentially what you're looking, this is the final result of what you're targeting. You want to have a pipeline where you're removing data, checking for constraints, making sure that we fit with the business profile, or business rules rather, and then have everything being automated from A to Z. When we get each and every time, but rather we want to build a pipeline so that things are more jobs. We don't do everything manually, but rather we set things up so that it can be more automated. So this is what I was trying to get at. And obviously to get to this point, we need to know how to clean the data, how to validate it, getting the rules from the business rules from the subject matter expert, incorporating all that so that essentially we end up at the very far right with the clean data. And actually, in all reality, we would take that clean data, train our models on it, and then be able to test the models, evaluate it, and either retrain it or publish the model. But everything from A to Z would be automated. Does that answer your question, Tolga, as well as Sean? I know it's a diagram, and I know you're probably anxious to get into more detail about it, but that is a course all in itself for a later time.
No, that's helpful.
Here's one extra question, Sam, which is maybe too big for this session, but do you have any tips on how to get useful information from the data owner?
Useful tips from the data owner. Give me an example or a scenario.
Maybe the name in your previous example is sensitive to international formatting, so lowercasing would be a bad thing for your ML. So like a Vanderwiel in the Netherlands, where I live, would be lowercase v, lowercase d, whereas in America it would probably all become capital V, lowercase everything else, one word.
Yeah, so basically to sum up that question is how well do you need to, or how much time do you need to spend with your subject matter experts? I would say it depends, especially when you're dealing with foreign entities. Now you're entering into a whole different realm. Probably work side by side, at least for the first iteration of data. So that way you know the ins and outs and what to do and what not to do. And then things could be a little bit more, you could run a little more independently afterwards. I'm sorry I couldn't give you a more concrete answer. It's a big it depends type of answer.
Yeah, I've had the experience that nearly always it becomes an iterative process.
Yeah,
and I never have a sense how close I am to the end until I've done a lot of validation.
it's I mean, I see it as something that you know, if I was to graph out the relationship with the SME for every iteration of the data, I would say it kind of like it's going to plateau eventually, right? Where first you need to spend a lot of time with them, and then it's going to level off and lessen.
Yeah. Okay.
I have a similar question but it's on the other side. After you go through this pipeline and you reach your clean data, how do you grade your clean data? How do you know your constraints weren't too tight and you lost too much data, or it was too weak, now you've got bad data? How do you judge your clean data? Is that a manual process? Is there automated tools you can run against it to test and grade, or is it just the business user looking at it? How do you know you did a good job?
So after you train your machine learning model, you should then have a set of data that you're going to test it against, and then be able to compare the results you're getting from the model with the results that you have in the I don't want to say with the test data, essentially, right? So for example, we'll make things simple. I know that a 1,000 square foot home, for example, should be 100,000, right? And so after I train my model on the housing prices, I'm going to feed it in the features that I have in my test data to say, this is a 2-bedroom, 1,000 square foot home. What should the price be? And it should come back with 100K. Obviously, there's going to be some variation there depending on the data, but let's say it comes back at 32K. Well, now I got to look at my data. What did I feed it in order for it to skew that output value? Make sense? And
Would
yes,
you build that into your pipeline, or would that be a completely separate testing step afterwards?
Both. So it would be a separate step afterwards, but that can also be automated. Essentially, what I'm looking to do is, this is the data cleaning pipeline. The end goal here for this presentation is to get to clean data. But then the very next step, further right, would be to take that, train a model, and it's going to be a cyclical fashion where I'm training it, testing it, and then either retraining it again, or I'm publishing it out to production. Make sense?
Yep, got it. So is it the loop there between the validation and cleaning step?
Is there a loop between the validation and the cleaning step?
Yeah, is that where the loop is? Like you're cleaning,
No.
validating, cleaning, validating, or is it the whole pipeline? You reach the clean data, test, and then go back to cleaning.
So after I get the clean data, then I would train my model. And then after I train my model, I need to evaluate it on a specific data set that I have with the outputs, and then see how well it does with that.
No, that makes sense.
Then obviously I have to look at the data that I fed it in, and I may need to have an entire new data set, which brings me back to the far left of raw data that I'm bringing in. But typically, like in a machine learning type scenario, or ML ops, for example, we've all heard of DevOps. ML ops is where I have the entire cycle from A to Z. I get chunks of data that I then cleanse. I do the validation. Then I take that clean data, train, evaluate, and then make a decision whether to publish the updated model or to retrain it some more. So I see one head shaking. Anybody else in agreement or any questions? All right, a lot of thumbs up. Very good. Danielle, you have a question. Go ahead, please.
Wrong button.
Wrong button. All right, very good. Okay, if there's no other questions or comments, one additional thing I wanted to touch on is if we're training our model on imagery and either reading images or developing images, if I'm feeding it images for training, I need to resize and normalize so that it's a consistent shape for all the images that I'm passing in. I need to remove corrupted or low-level resolution or something that may be blurred, and removing noise from images or denoising, and that includes removing any blurs from it. In addition, any color correction as well, and removing the background to avoid skewing the machine learning models. That will at the object in question. So that brings us to near the conclusion of our presentation. And I always like to ask, what did you learn here today? So if someone was to ask you, what did you spend your Thursday evening learning about? What would be your answer? Again, either in chat or verbally. Go ahead, Sai.
So this question is with regards to bias in the training data. Let's say if we created a model and that model needs to be trained based on the data that we get every day. There are a lot of new LLMs into market and they train continuously. Based on our business rules, is there any bias check that you do regularly, or how do you monitor that bias in learning?
Okay. Good. I see that question going in either two directions, meaning could my data be biased that I'm processing, and how do I detect on that?
Yeah.
Or okay, that's what you mean by that. So I would, as we had mentioned earlier, you want to make sure that you have a good representation of the data. So if I'm looking at housing prices, I shouldn't be looking only at 3-bedroom homes within a specific area, but rather have a good representation of everything. If you have rather a focused data set, that's going to cause overfitting and it's going to be biased towards the output value. So you want to have a good representation of all the possible candidate values. But also another point, if you recall from the very first demo that we did I close that? There it is. So you want to question, first of all, how was that data collected, right? Because if I didn't point this out to you or to my user, they would be choosing one of these 3 options, right? So how was the data collected? Was there any factors that may have forced the data to be biased? Meaning, was there a government incentive to buy only 2-bedroom homes, for example? And that could skew the data and make it biased. Does that make sense?
Mm-hmm. Yeah.
All right, very good. Any other questions? Okay. So another thing that I mentioned earlier is just because we're coming to the conclusion doesn't mean the dialogue stops here. You can find all my socials on Linktree for both my LinkedIn, YouTube, and everything else under the sun, all on Linktree/Sam Nasr. More specifically, my email, snasr@nistechnologies.com, the link to my socials, as I mentioned earlier. And if we're not connected on LinkedIn, I think it's a great platform for keeping in touch, sharing articles and commentary. So strongly urge you, if we're not connected on LinkedIn, please let's do so. So with that, thank you all for attending. Appreciate you taking the time. Hope it was helpful. I am definitely open to any constructive criticism, any feedback, either now or later. You have my email, so I look forward to hearing from you. Tolga, my answer to what I've learned Databricks is not just one thing, but the orchestration of various tools used to arrive to clean data. Yes, indeed. Like I said, there's a lot to be learned from, or to learn about Databricks, far more than we can discuss in 1 hour. I just gave you a little caveat of the cool things that you can do by making Python calls. You already have the data, and you're able to open a notebook within Databricks. So it's one-stop shopping for doing your data massaging and manipulation and cleansing. but then you can also store it back into that same database in Databricks. And thank you, Sai. Thank you, Tolga. Thank you all. I appreciate the questions. It was definitely a great dialogue, and would love to be back again. So thank you all.
We'd love to have you. Thank you so much, Sam.
Thank you, Sam.